Hello students, in this session we shall discuss exercise 2.4 of class 9 maths. Now first you see the factor theorem. If px is a polynomial of degree n greater than or equal to 1 and a is a real number, then number 1, x minus a is a factor of px if pa equal to 0, and number 2, the number 2 is the converse of number 1, pa equal to 0 if x minus a is a factor of px. So suppose I am randomly considering a polynomial, so px is equal to x minus 2. Okay, now here factor theorem says that if x minus a is a factor of px if pa equal to 0. So here if we place p2, then 2 minus 2 equal to 0, then you can say x minus 2 is a factor of px this way. And conversely, if p2 equal to 0, then if conversely x minus 2, if it is given x minus 2 is the factor of px, then we can definitely say p2 has to be equal to 0. This is the factor theorem. Now we shall see the use of factor theorem in exercise 2.4. Let's start it. This theorem is very easy. You can understand after doing the sums of this exercise. Number 1, determine, you can refer your book exercise 2.4. You see there are 4 sums in number 1. Determine which of the following polynomials has x plus 1 as a factor, and you have to determine among the following polynomials which has the factor x plus 1. So we have to use the factor theorem. Say first time saying x plus 1, this is plus sign is there, so we have to arrange in the form of x minus a, because in our theorem it is in the form of x minus a. So you have to, if we arrange this, it will be better. So value of a is here is minus 1. Now we have to check. So we shall put we shall find pa in each case. So let's do number 1. Let us consider the polynomial p x is equal to x cube plus x square plus x plus 1. All right, now we have to check if x plus 1 is the factor of this or not. Therefore p minus 1, minus 1 cube minus 1 square minus 1 plus 1, this is minus 1 result is 0. Therefore you can say x plus 1 is according to factor theorem, if p equal to 0, then x minus a is the factor of px. Then you can say x plus 1 is a factor of px. Okay, this way you have to do the others. Next is number 2. Use the factor theorem to determine gx is a factor of px in each of the following cases. So there are two polynomials, px equal to the this number 1 and gx equal to this. So same you have to find whether gx that is the latter polynomial is the factor of the former polynomial. So we shall use here given first px equal to 2x cube plus x square minus 2x minus 1, and gx equal to x plus 1. We can arrange it x minus minus 1. Therefore p minus 1. Into minus 1 plus 1 plus 2 minus 1. So p, again we have got the p equal to 0, therefore we can say that gx is a factor of px. Okay, next say the number 3, find the value of k if x minus 1 is a factor of px in each of the following cases. See, here you have to find the value of k and you are given x minus 1 is a factor of px in all the polynomials. There are 4 polynomials are there. So in each case we have to find the value of k. So you are given x minus 1 is a factor of px. So definitely p1 must be 0 as per the factor theorem. See, x minus a is a factor of px if p equal to 0, or p a equal to 0 if x minus a. So you are given x minus a is a factor of px. So p a must be equal to 0. So this we can use. We are given first to write the polynomial px equal to x square plus x plus k. Therefore p1 x minus 1 p1 1 square plus 1 sorry therefore p1 must be 0 as per the factor theorem. Then you place 1 in place of x, 1 square plus 1 plus k equal to 0, 2 plus k equal to 0, so k equal to minus 2. This way you try the others, you can find the value of k in each cases. Let's see the next one. See the number 4, factorize. x square minus 7x plus 1. Now here we have to factorize. We shall factorize by splitting the midterm of the polynomial. I repeat, here we shall factorize the terms by splitting the midterm. But how can you split? There are some rules. You see, we need to multiply or multiply the coefficient of x square or y square or whatever be the variable, the coefficient of x square with the constant term. So here coefficient of x square is 12 and constant term is 1. So 12 into 1 result is 12. Right? Now we shall factorize 12 and choose two factors among the factors. I mean, we shall find the two factors of the 12 in such a way that if we add these two numbers, by adding two factors, we shall get the 7. Why we should add or why we should subtract? This we can understand by the sign of the constant term. We have to check the sign of the constant term, whether it is plus or minus. If it is plus, then we have to choose the factors in such a way that by adding the factors we should get this coefficient of the midterm. And if the constant term is having the negative sign or minus sign, then we have to choose the factors in such a way that after subtracting the factors we get the coefficient of the midterm. All right, now let's see how can we do. If you see this, you can understand. See, let's start factorizing 12. Okay, now here plus sign is there, so we had to obtain 7 by adding the factors. There are 3 factors, but if we multiply this to 2 into 2, it will be 4, and 4 and 3 will be 2 factors. If we add 4 and 3, 4 plus 3 will be 7. So in bracket we have split the 7 as 4 plus 3. So 12x square minus 4x, remove the bracket, minus 3x plus 1. Now there are 4 terms. We shall take the common from these two and these two. What should be taken common from these two? 4x can be taken common, and there will remain 3x minus 1. Similarly, from 3x and 1 there is no common factor, so we can take the 1 common. 1 is common to all the factors. Minus 1, so 3x minus 1. Now see, minus 3x minus 1, 3x minus 1. This term also have 3x minus 1, and in this term there are two terms, as the minus sign is there. So 3x minus 1, 3x minus 1 factor, this can be taken common, 3x minus 1. After taking 3x minus 1, there will remain 4x minus 1. So this way we have got the factors. Alright, I am showing one from negative sign and see. I am showing you the number 3. 6x square plus 5x minus 6. Now first we shall multiply the coefficient of x square with the constant term. 6 into 6, 36. Okay. Now factorize it. Prime factor, we are doing the prime factorization. Okay. Now negative sign is there. Constant is having the negative sign or minus sign. So we have to obtain the midterm, coefficient of the midterm by subtracting the factors. But we have to choose the factors first. See, all the factors we have to take. I mean the two factors of 36 we have to choose. Now here 3 3 is 9. If you multiply 3 3 is 9 and 2 into 2 it will be 4. So 9 and 4 are the two factors. If 9 minus 4 we do, then we can get the 5. This factor choosing is the main thing in this type of sum. Here these things are very easy, but in some middle terms, middle term factorization, splitting factorization, it is very difficult to choose the factors. So we be very careful about choosing this. So we can write 9 minus 4, x minus 6. Alright, remove the bracket. Take the common. What can be taken? 3x we can take the common, and there remain 2x plus 3. From these two terms we can take common? Minus 2 and 3x minus 3. Sorry, 2x plus 3. Now again 2x plus 3, we can take this common, and there will be 3x minus 2. This way you can factorize. Alright, and if the polynomial, quadratic polynomial is not arranged in this way, you have to arrange first and then start factorizing. Okay. Now see, number 5 I am showing. So number 5, 2 I am showing. Now see this, first you consider the polynomial at px equal to x cube minus 3 x square minus 9x minus 5. Okay. Now we have to factorize by trial and error method using factor theorem. Okay, because this is there are 4 terms and this is a cubic polynomial. So trial and error method, first we shall start from the 0, p0. So place the 0 in place of x. See, all these terms will be 0 and result will be minus 5. So p0 is not equal to 0. If p0 is equal to 0, then x minus 0 must be the factor of this. So this way it won't work. Next we test the first we shall start with the 0, test with the 0, then we shall test with the 1, and then we shall minus 1, then 2, then minus 2, then 3, then minus 3. This way we shall proceed. So let's check for 1. 1 minus 3 minus 9 minus 5. what would be the result? This is not equal to 0. Next check -1. So -1 cube -1 -3 plus 9 -5. Now if we add all the negative sign numbers, this will be -9 plus 9, applying Badmas. So plus 9 minus 10 is 0. Now see, we have got p minus 1 is equal to 0. Therefore, as the p minus 1 is 0, therefore x plus 1 is a factor of px, definitely. Okay. Now we have to divide this polynomial, given polynomial, by x plus 1. Let's divide this. We shall perform the division in the next page. It would be easier. So polynomial is x cube minus 3x square minus 9x minus 5. So division, you know this division. First you divide the first term with the first term of this polynomial. So result is x square multiply x cube. So we have to get this 4 by subtracting the factors of 5 and 1. So 5 is the prime number, we cannot factorize it, but 5 into 1 is equal to 5, we know this. So 5 and 1 is the factors of 5, definitely. So we can write it 5 minus 1. So x square minus 5x plus x minus 5. I have removed the bracket. Now take common. X minus 5 plus 1 x minus 5. X minus 5 plus into x minus plus 1. Now see, you have got another two factors. Therefore px was the original polynomial. It has two factors, x plus 1, x plus 1. Two factors are the same, and another is x minus 5. This way we can factorize the